Determine all intervals of concave up or concave down, and determine the coordinates of all inflection points, including cliffs, for the function f of x equals x divided by x squared plus 12. The first thing to do is find the domain. F of x equals x, a polynomial, the domain would be all reals, divided by x squared plus 12, which is also a polynomial, and the domain would be all reals, but we do have a denominator here, and the domain requires that the denominator cannot equal 0. So x squared plus 12, the denominator, does not equal to 0. We can solve for x by subtracting 12 from both sides, so x squared does not equal negative 12. And then taking the square root of both sides, x does not equal plus or minus the square root of negative 12, which is an even root of a negative number, and the even root of a negative number is not a real number. So we have plus or minus what is not a real number. So there are two non-real numbers that x cannot be, but x can be any real number, because no real numbers will make the denominator equal to 0. So the domain will be all real numbers, or negative infinity to positive infinity. The next thing to do is find all candidate numbers. We will need the second derivative for this. We will start with the first derivative. F of x is the quotient of two expressions of x. So we will make use of the quotient rule for the first derivative. F prime of x equals the derivative of the numerator, which is a 1, times the denominator left alone, x squared plus 12, minus the numerator left alone times the derivative of the denominator, which will be a 2x, and the entire thing over the denominator squared. In the numerator, we can distribute the 1 in, which will give us x squared plus 12. We can multiply the negative x and the 2x, which will be negative 2x squared. We'll leave the denominator as is. We can combine like terms together in the numerator. There's an x squared and a minus 2x squared, which will be negative x squared and a positive 12. We can write the positive 12 first, and then the negative x squared all over x squared plus 12 quantity squared. We can take the second derivative from here. The first derivative resulted in what is a quotient of two expressions of x, so the second derivative will also require a quotient rule. F double prime of x equals the derivative of the numerator, which is a negative 2x, times the denominator left alone, x squared plus 12 to the power of 2, minus the numerator left alone, 12 minus x squared, times the derivative of the denominator, which is a power rule. We'll bring the power down at 2, leave the inside alone, x squared plus 12, subtract 1 from the power, and then multiply by the derivative of the inside to complete the chain rule. All of this will be over the denominator squared. It's already squared, so we will square it again. The first term in the numerator, there's a minus 2x, no need for the parentheses, and then an x squared plus 12 squared. In the second term, we can put the constants together. There's a 2 and a 2. 2 times 2 is 4. It can move out front. There's a negative already out there, so it'll be a negative 4. There's an x that can move out front with it. There's a 12 minus x squared. And there's an x squared plus 12. All of this is over x squared plus 12 squared, and then squared again. We multiply the exponents here. So 2 times 2 is a 4. It'll be x squared plus 12 to the power of 4. We want the second derivative as a single fraction. It already is. We want it fully factored. In the numerator, there is some common factors. There is a -2 and a -4, so we can factor out -2. There's an x and an x, so we can factor out an x. So -2 and an x. And we can also factor out the lowest power of x squared plus 12, because there is an x squared plus 12 in each term. It's to the power 2 here and to the power 1 here. So we can factor out an x squared plus 12 to the 1 power. After factoring this out, it will leave behind. Factoring out the -2, this will become a positive 1. This will become a positive and will be a 2. We factored the x out, so it's gone here and here. And we're factoring out 1 power of x squared plus 12. Factoring is division. Division is subtraction of exponents, so we will subtract a 1 from the 2, so it'll become a 1. And subtract a 1 from the 1 power here, and it'll become a power of what will be 0, and anything to the 0 power is a 1. So there's what we'll have left. It'll be an x squared plus 12 plus 2 times 12 minus x squared. It'll be an x squared plus 12 minus 2 times 12 minus x squared. This entire thing is over x squared plus 12 to the 4th power. Now we just factored out an x squared plus 12, so we can cancel down. It's to the power 1, so we can cancel one of them out with one of them in the denominator, which will leave 3 of them in the denominator. So f double prime of x equals, in the numerator there's a -2x. In the square brackets there's an x squared plus 12. And we can distribute the -2 in here, which will be a -24 plus 2x squared. And all of this will be divided by x squared plus 12, and then quantity cubed. So we have in the numerator a -2x, and we can combine like terms in the square brackets. It can turn into parentheses now. There's an x squared and a positive 2x squared. 1 plus 2 is 3, so 3x squared. There's a 12 and a -24. Those will combine to be a -12. And then all of this over x squared plus 12 cubed. We want the second derivative to be a single fraction. It is. All powers to be positive. They are. And we want it to be fully factored. There is a common factor of 3 in the parentheses in the numerator. We'll factor the 3 out. It'll move out with the -2, so it'll become a -6. And there's an x. Factoring out the 3 will leave x squared minus 4, which is a difference of squares. We'll leave the denominator alone. The difference of squares can factor further into x plus 2 and x minus 2. still leaving the denominator alone. The denominator is a square term plus, so it's a sum of squares, which does not further factor, so we're just leaving that alone. So we now have the second derivative as a single fraction. All powers are positive. It is fully factored. We can set the numerator equal to 0 and the denominator equal to 0 and solve for all x's. Starting with the numerator, negative 6x times x plus 2 times x minus 2 equals 0. It's already factored, so the x will tell us that x equals 0. The x plus 2 will tell us that x equals negative 2. And the x minus 2 will tell us that x equals positive 2. For the denominator, we have x squared plus 12 cubed equals 0. We'll start by taking the cube root of both sides. The cube root and the cube power cancel each other out, and we have x squared plus 12 equals, the cube root is 0, which is a 0. We can subtract 12 from both sides, so x squared equals a negative 12. We can take the square root of both sides, so x equals plus or minus the square root of negative 12, which is once again an even root of a negative number, which is not a real number. We want to check to see which of these are in the domain. Well, x equaling a non-real number will not be in the domain of real numbers, so we can cross that out. But the x equals 0, x equals negative 2, and x equals positive 2 are all real numbers. They are in the domain, and they are all going to be candidate numbers to be possible inflection points. We can now draw a domain line, a line representing the domain. It has no left end because it starts at negative infinity. It has no right end because it ends at positive infinity. We can put all candidate numbers on here in order. Negative 2 will come first, then 0, then positive 2, which will split the domain interval up into 4 separate intervals. We can pick a test value in each of the intervals. The first interval is negative infinity to negative 2. We can pick negative 10 in there. The next interval, negative 2 to 0. We can pick negative 1 in there. Next interval, 0 to positive 2. We can pick 1 in there. And then 2 to positive infinity. We can pick 10 in there. We can now test the concavity by plugging the test values into the second derivative. We don't care about the value of the second derivative, just whether it is positive or negative. Therefore, the best version to use is the fully factored version, which is this one here. Now, a couple things about this. In the denominator, we have what is x squared, which will be positive or as low as maybe 0 to plug into it. But then it's added with 12, and that means that it's a positive number. And then the entire thing is cubed. And a positive number cubed will be a positive number. So that denominator is always positive, and therefore does not affect the sign of the second derivative. So that portion doesn't matter. In the numerator, there is a negative 6. Just be sure to account for that to get the proper positive or negative sign for the concavity. But the full numerator does matter. Plugging in negative 10, we have negative 6 times negative 10. Negative times negative is positive. We have a negative 10 plus 2. That will be a negative, and a negative 10 minus 2. That will be a negative. So we have negative times negative is positive. We have a total of 4 negatives here. It will be a positive. A positive second derivative corresponds to concave up. We can now plug test value of negative 1 in. Negative 6 times negative 1. Negative times negative is positive. Negative 1 plus 2 is positive. Positive times positive is positive. Negative 1 minus 2 is negative. Positive times negative is negative. We have a negative second derivative, which corresponds to concave down. Plugging positive 1 in, negative 6 times positive 1 is negative. 1 plus 2 is positive. Negative times positive is negative. And then 1 minus 2 is negative. We have a negative times a negative, which is positive. We have a positive second derivative, which corresponds to concave up. And last of all, the test value of positive 10 plugged in. We have negative 6 times positive 10. That'll be a negative. 10 plus 2 is a positive. Negative times positive is negative. And then 10 minus 2 is a positive. Negative times positive is negative. We have a negative second derivative, and that corresponds to concave down. So we have concave up happening from negative infinity up to negative 2 union, because it is happening again from 0 to 2. We have concave down happening from negative 2 to 0 union, because it is happening again from 2 to positive infinity. Right at the candidate number of x equals negative 2, we have the concavity changing from concave up to concave down. So x equals negative 2 will be an inflection point. So we have an inflection point at an x-coordinate of negative 2, and it will have some corresponding y-coordinate, which can be found by plugging the x-coordinate back into the original function. So y will equal f of negative 2, which will be negative 2 divided by negative 2 squared plus 12, which is negative 2 over negative 2 squared will be positive 4 plus 12. So this will be negative 2 over 16. We can reduce by 2, and it will be negative 1 over 8. There's the corresponding y-coordinate, negative 1 over 8. Right at the candidate number of x equals 0, we have the concavity changing from concave down to concave up. So x equals 0 will also be an inflection point. And it'll have some corresponding y-coordinate, which can be found by plugging the x-coordinate back into the original function. So y will equal f of 0. And that will equal 0 over 0 squared plus 12, which is 0 over 0 squared is 0 plus 12 is 12. And 0 over any non-zero number equals 0. So it has a corresponding y-coordinate of 0. Or by being 0, 0, it's the origin. Right at the candidate number of x equals positive 2, we again have the concavity changing from concave up to concave down, so x equals positive 2 is also an inflection point, and it has a corresponding y-coordinate, which can be found by plugging the x-coordinate back into the original function, so f of positive 2, which will be positive 2 over positive 2 squared plus 12, which is positive 2 over 4 plus 12, which is 2 over 16, which can reduce to be a positive 1 over 8. So it has a corresponding y-coordinate of positive 1 over 8. So we have 2 intervals of concave up, 2 intervals of concave down, and a total of 3 inflection points, one at negative 2 comma negative 8, one at the origin 0 comma 0, and one at positive 2 comma positive 1 over 8.